Okay, so today we're going to discuss 1.1, which is real numbers, and 1.2, hopefully you all remember, very important is interval notation. Yeah, so let's talk about the real number a little bit. So I am going to share my desktop. All right, where is my journal? Okay. So 1.1 is real numbers. Oh, it's red. So 1.1 real numbers. So you can go ahead and take notes while I'm doing it. This is your first lecture, right? So if I'm too fast, let me know. I tend to be on the slower side so that you have time to write down and think. Yeah. All right, so let's talk about sets, okay, and interval. And we will go through this really quickly because this is very basic and it's review. So what is a set? So a set is a collection of elements. So if you already know, you probably don't want to write it down, or you can write it down. A collection of objects which are called the elements of the set. So, for example, if I have a set of 4 first natural numbers, so if I want a set of first 4 natural numbers, I should have said that. What are the first 4 natural numbers that you know? Good? Okay. Well, is 0 included? No. So natural numbers are counting numbers. So you count with 1, 2, 3, 4, right? Not from 0. Then we will say that, so the 1 is an element of S. So this symbol, you probably seen this. This is red S is an element of, right? So it's like an epsilon. It's a Greek letter. Okay. And how do we say it's not an element of? So we will just say is not an element of S. All right. Okay. Now, we could also write this. This is a subset. So if I write 1 and 3, this is a subset of S. So this is like C, but not really C, is a subset. All right. So subset is a smaller set. It is a part of a larger set. Are we okay so far? Can you tell the difference when I use the is an element of, or when I use the something like C, which is a subset of? Yes? Okay. All right. So this is the symbol of an empty set. Or I could write it like this. So this is the symbol of an empty set. Okay. What about union? What does union mean? So suppose I have my next symbol. So this is an element of, right? This is a subset of. This is the symbol of an empty set. Next one is union. So can I ask you, what are the first 5 prime numbers? So give me the first 5 prime numbers. What is it? 1, 3, 5. Is 1 a prime number? No, prime number starts with 2. Yes. So 2 is the only even prime numbers. You know why? Why is 2 the only even prime numbers? So how come 4 is not a prime number? is divisible by 2. So 2 is the only even prime numbers. So 2, 3, 5, 7. What about 9? No, 9 is divisible by 3. So what do we call numbers such as 9, 4? Composite number. Yeah. So this is the set of the first 5 prime numbers. So now the S is the S that we have. So what about if I say A union B? What is A union B? So what does union mean? So U, this is the symbol, is a union of. All right. So U is a union of. What is A? I'm sorry, I'm not even declaring my B, do I? Did I? So A union S, that's what I mean. And somebody tell me, what is A union S? This is pretty simple. Yes, which is?
2, 3.
Yes, so do we start with 1? 1, 2, 3. What about 4? 4, 5, 7, 11. So notice that I do not list 2 twice. So, you know, S has 2 and A has 2 also. So both S and A has 2 and 3, but I do not list 2 and 3 twice. Yeah? Okay. So A union S is 1, 2, 3, 4, 5, 7, 11. Okay. Now, what about a intersection S? So this symbol is an intersection of. All right. So what is the intersection of A and S? 2, 3, and what is it? 2, 3, and 11? 2 and 3. That's it. Yes. All right. Okay. All right. So it's an intersection of A and S. Is it pretty simple? So if I draw the Venn diagram, how would it look? Do these 2 sets intersect? Yes. So, Okay, so if I draw the Venn diagram, I'm going to write, oh, this is my A and this is my S, and there are 2 intersections, 2 elements in the intersection, which is 2 and 3. All right. What else do I have in A? 5, 7, 11, and this is 1 and 4. Yeah. If I were to draw S, it doesn't matter A first or S first, right? And this is a set, so the order doesn't matter. So for S, I could write it as 2, 1, 3, 4, or 4, 3, 1, 2. So for a set, the order doesn't matter. Yeah. Are we okay so far? You remember all the union and element and subset is a subset of? Okay. All right. Oh, maybe I should write down a union S contains all elements that are in A, B, or both. Maybe I should write this first, right? So maybe let's label this. So let's label this is an element of, this is a subset of, this is the union, okay? And this is the intersection. What does a intersection S contain? So, oh, I don't have space to write down. So, A intersection S contains the elements common to both A and B. Both A, and B. So the keyword for intersection is and. The keyword for union is or. Okay? So or and and. All right. So the next one that we're going to do is talk a little bit about interval notation, just to remind you what they are. Interval notation. Okay. And there is set builder notation. All right. Then after that, after we do several examples, then I'm actually done with 1.1. So 1.1 is really short. Okay? All right. Are you guys ready? So if you come late, maybe you could take pictures or something like that. Yeah? Because I'm going to the next page. So how is the pace so far? Are we okay? Not too fast? Too slow? A little bit, right? Okay. That's okay. So B, we will talk about interval notation. All right. So let's see. So I'm going to write a few intervals, and then I'd like to graph it, and then graph, and then interval notation. And I also want to write down the set builder notation. All right, so all right. So number 1, x is greater than 5. Number 2, x is less than or equal to -3. Number 3, x is between -2 and 5. Number 4, all real numbers. All right. So I'd like to graph these on the number line. Actually, let me move this a little bit. Okay. So how do I graph it on the number line? X is greater than 5. Yeah. So 5. I'm going to use a little bit different, so I'm not going to shade it because it's really hard to see. Okay. But I'm going to tell you what Math Excel does. All right. So this is what I will use. 5. Is it open or closed? Open. Why is it open? It doesn't include 5, so it's going to look like this. Why is my arrow pointing to the right? Greater than 5. Yeah, it's greater than. Now, this is what Math Excel does, so or some books does, but I don't think it is convenient, so this is an alternative way to graph. Look at this. So in Math Excel, you're going to do 5, and then you're going to do this. Okay, but it's really hard to see, isn't it? So that's why I'm using this one. Yeah. So in class, whenever I graph something in real numbers, then this is what I'm going to do instead of this. But these two are exactly the same. Yeah. Now let's write down the interval notation. Is 5 included? No. So do I use parentheses or bracket? Parentheses. What's the smallest one? 5 to infinity. Okay. So if you remember the interval notation, so let me write here. Interval notation So it uses the parentheses for less than or greater than, and a bracket for less than or equal to, greater or equal to infinity. So infinity, negative infinity, next to it we need to use parentheses, and it always starts with the smallest one, right? With the smallest element. All right. So how do I write my set builder notation? How do I write my set builder notation? So remember, this is x such that what? X is greater than 5. And then this is optional. X is an element of real number. So this part is optional, this part right here. Yeah. If we don't write it, we assume x is an element of real number. So sometimes you just write it like this, x such that x is greater than 5. All right. And we don't include x is an element of real number. So we just assume it's all real number. All right, what about number 2? What should we do here? -3, open or close? Close. And the arrow points to the left. Okay. All right. Now, how does MathXL do it, or some of the books?
Square bracket.
Yes, square bracket. And then the arrow is to the left. Why is it square instead of, look at this, this is like a parenthesis. Yeah, it includes -3. All right, so how do I write my interval notation? What's the smallest on the solution? Negative infinity. And I have to use parentheses, comma, -3, bracket. Yeah. So for infinity, we don't have any choice. We use the parentheses. How do I write my set builder? X such that x is less than or equal to -3. So I could write x is an element of real number, or I don't have to. So it's optional. Yeah. So these, I could write x is an element of real number, or I don't have to. All right. Okay, next is pretty easy also. What do you do? -2, open, close. Open 5, close. Okay. So how do I write my interval notation? Yeah. Okay. So this one is x such that -2 is less than x, less than or equal to 5. Right? Okay. Pretty easy. So if I were to do it in MathXL, then I am going to do, what am I going to do here at 2? Oh, I have to put a number here. So 2. What am I supposed to do with 2? Yeah, and then this is yes. Okay. So this is closed. This is open. Do you guys remember this? Yes. Okay. Oh, good. I'm glad. Yeah. All right. So next, all real numbers. How do I draw all real numbers? Well, I mean, it's just your number line. Yeah. What is your interval notation? -infinity to infinity. And what about your set builder? You can write these, or x such that x is an element of real number. Either way. All right. So we're done with 3/4 of 1.1. So purely review. Are we okay so far? Okay. And I'd like you to find and graph each step. Okay. All right. Are you ready? Yes, we are ready? Okay, let's continue. All right. So, the next one is write the solution. Oh, sorry. Graph and write the solution in interval notation. All right. So, number one, 1, 4, intersection 3, 10. So, number 2, 1, 4, union 3, 10. Number 3, negative infinity to 6, intersection 2, 10. Number 4, negative 4, 6, union 0, 8. 0, this is 8. I'm sorry. It looks like infinity. This is 8. All right. So what we're doing here is we're combining what we learned earlier. So I'm going to start with 1, and then I think you guys could try the others, right? Okay. So 1.2 is a little bit longer. 1.1, we're almost done. All right, so continue? Okay, so let's draw the first interval first. So what we're going to do is draw these two in the same number line. Yeah. So 1, 4, how do I draw 1, 4? Open or close? Open at 1 and open at 4. Does it look like it's closed? I mean, I should probably draw a bigger circle, right? Okay. And then it's in between here. Oh, sorry. Did I draw that for my 2 and 5? I'm sorry. Can I backtrack a little bit? Oh, yeah, I did. Yes. How about 3, 10? What am I doing here? So this is 3. Where is 3? 3 here. Open or close? Close. Where is 10? Oh, somewhere here, but let me just draw it here. And what else am I going to draw? Something like this? Okay. Now, the question is, which one is the intersection? 3, 2, 4? Why do you say it's the intersection? That's the common, yes, overlapping. So it has 2 lines. So in my terms here, it has 2 lines, you see? So yes, so between 3 and 4 is common. So this is your solution. How do I write the solution? The solution, bracket, 3, 4. All right. Good. Now, I'd like to give some time and let you try number 2, 3, and 4. All right. So maybe 4 or 5 minutes, and then you could talk to the person next to you, and then compare your answers. Okay. And who came late today? I already called the attendant. So many. So tomorrow you guys are coming on time, right? Because I'm going to call attendance. Oh, tomorrow, no, Tuesday. Yes. Tuesday, you're coming on time?
Monday?
Monday is Labor Day. Monday is Labor Day. Yes. Okay, so who's next? Okay, blessing.
Ayun. Eh, why not?
Okay. Blessing.
Why?
Okay, blessing.
Friends?
Hernandez. What's the other?
Scared? Q-U-B-O?
Move. Rich. Oh, sorry, Siswanto. How about Richard? You know what the 22 days? No, actually 2 days is Monday and Wednesday. So I'll talk to you after. Thursday, is it hosted? So, I'd like students to come on time. Yeah. So I'm going to call attendance 2 minutes after, so it's around 7:42, because after that I'm going to start recording. So I'd like to call attendance before recording. Yeah. Before I used to do it after recording, but I don't think it's a good idea. I do it before recording. Okay. Okay. So are we working on it? So that's answer 1 and 2. Is it or is it? Okay. One is intersection, the other is meaning. Are you done? No. Here's how many pencils. So when you take one card, you take pencil. So you're not afraid of trying. Because if you use pen, and then what happens is you don't try it. And if it's not, no problem. You can just use it. Very important to try it. Yeah. So, what is this very it doesn't let me edit the end. So it's like if you want to learn any skill, like what? What do you like to do? What sports do you like? Anybody want to say what their sports they like?
Soccer?
Okay, soccer. Can you learn soccer just by watching somebody else play soccer? Not really, right? So you gotta go to the field and then kick the ball, right? Same thing here. Can you learn calculus by watching me learn calculus? Yeah, you can, but afterwards you have to do it too. So this is the place where you get your speak dirty, where you pick up the soccer ball, so it's the same. You pick up your pencil and do it. So when we have time in class, and I dedicate time for that, you should do it. That's why I would really recommend using pencil. So if it's dry, so what? No big deal. Just erase it. Right? Yeah. If you use pen, then you're probably a little bit scared, so you want to wait. But that's not a good idea. Okay. All right. Okay, 2 more minutes, and then you're going to compare your answers to your next door neighbor. Or if you're done, you can compare it to your next door neighbors. So done. And then see. So you got to start talking to your next door neighbor. Why? What's so hard about children?
I forgot it. So, I haven't done, the last math class I did was, spring.
Which one, 3 and 4?
Yeah. Oh, no. I forgot how to write it. So, I know how to graph, I just forgot how to write it.
Okay, well, you can take all the elements on your problem on the market. So, and it's a location. So, your answer will be your location, and you can do everything. Okay? Are you done? So, if we're talking about union, which one is the union?
Yes, I got it.
Alright, did everybody have a pair? Okay. Alright. Let me see. No, if you want to add, you should stay here. I just want to know whether about these people are related or are they not coming. Yeah, I think so. I think you can add. Okay. All right. So, did you talk to everybody? Well, you talk to your partner. A partner. It doesn't matter who it is. It's just somebody next to you. Yeah, maybe as I said later on, you might be able to share phone number to whoever you're comfortable with, or share email. All right, so are we ready to start? Okay, do you want to tell me how to do number 2? So how do I graph 1 and 4? 1 open, 4 open, and then it's in between. All right, good. How do I graph 3 and 10? 3 close, 10 close. Okay, and I have to graph it a little bit higher, right? Or it doesn't matter as long as they have different heights. Now, this is union and this is intersection. What is the difference between union and intersection? Everything, at least one line on top. So if you remember, when I teach math 125, I always say this is an and, this is 2 lines. It has 2 lines on top. So the solution has 2 lines on top. So if you see for the intersection, which one has 2 lines between 3 and 4, it has 2 lines. It has this line, the bottom line, and the top line. Now, what about union? When I teach my math 125, I always say this is at least 1 line. So which intervals have at least 1 line? Between 1, how about 3? How about 3 and 4? Well, it's okay because 2 lines mean at least 1. Right? So what is my solution to this one? Parentheses 1, yes, comma, then, yeah. Are we okay so far? Okay. So if you didn't do it the way like this, what did you do? I was just wondering. Does anybody want to share?
Well, we were talking and
What is your name? Sorry, I want to remember everybody. What's your name?
Joshua.
Josh, yes, Josh.
Well, he thought that since it was open, that it wasn't included, and so we should try to check it. So instead of 1 to 10.
Oh, so you split it up? Well, okay. No, because the 4 is covered by the top. You see, there's a line on top of 4. Yeah. So no, in this case, we don't separate it. We don't separate the intervals. Good. So is it clear what the question was? So since this 4 is open, so Josh and what's your name? Jacob and Josh separate them, and that shouldn't be. Why? Because the 4 is included with the top, right? Okay. Because it has one line. 4 has one line, at least one line, which is on the top. Of course, it's not covered by the first line, but it is covered by the second line, which is on top. Good. Now, how about the second one here? Number 3, I'm sorry. Any other feedback for number 2? Are we okay? All right. How about number 3? What do you think? Negative infinity to 6. How do I graph that? No, you don't. So negative infinity, we don't put anything. Yeah, just the 6. Close or open? Oh, I'm sorry. 6 is to the right of 0. So my middle is 0. Right? So when I say 6, then I'm going to draw it to the right. This is my middle is 0. So 6 here, and then this is my. All right. How about 2, 10? 2 open. How about 10? Open, and it's in between. So you should draw 2 things that have different heights. It doesn't matter. It doesn't matter which one's higher, which one's shorter, but if you have 2 different intervals, you need to draw them different heights. Yes, because you need to see how many lines. So if I'm drawing it like this, for example, and then I'm drawing it like this, then what happens? You can't see which one has 2 lines, right? So in order to be able to see the 2 lines, you need to draw these lines at different heights. Does that make sense? Okay. All right. So which one is my solution? So what does M mean, or intersection means? At least 2 lines. Oh, I'm sorry, not at least 2 lines. 2 lines. You have 2 lines. The common one is 2 lines. So what will this be? Mm-hmm. Yes. Parenthesis 2, comma 6 bracket. Are we okay so far? Any questions? Can we continue? All right. The next one. Negative 4, 6. Negative 4, open, close. Close, 6. Open, and draw it. 0. Close, and 8. Open, and then we draw. And what does union mean? At least 1 line. So which point have at least 1 line? What is it? Negative 4. Oh, did you close bracket? Yeah. Negative 4, 2, 8. So it's this one. And then this one is this one, right? Are we okay so far? Okay, so you know the difference between intersection and union. Am I right? All right. Okay, so I'm going to save the notes, and then we will start 1.2. So can you tell me what you learned while I'm doing that? Can you tell me what you learned just now? Yes. What's your name? Andy. Yes, Andy. All right. What else? Or you can do it, or you can do it. Somebody else can do it. And what else, Andy? You still want to say it? That's it? Okay. What else? This is difference between union and intersection. Okay, what else? What else? That's it? What about the steps in simplification? Or you always remember this? So I'm doing exponents and radicals. So I'm done with 1.1. So we talked about the symbols in steps and we reviewed the interval notation. Am I right? Okay. So let's take 1.2 now. This is a little bit longer. I think we could probably finish maybe on Tuesday. All right. So exponents and radicals. So we're going to talk about laws of exponents really quickly, and then scientific notation and radicals, and last one is simplifying and root and rational exponents. So 1.2 is long. Let me see. I'm going to share the desktop again. Oh, and actually I'm going to close this and I'm going to open a journal. So 1.2 is exponents and radicals. This is a little bit longer. All right. So we're just going to write laws of exponents. This is review. And we're not going to prove it or anything like that. So the laws of exponents. What is a to the n multiplied by a to the n? Yes. Good. Not m times n. What is a to the m over a to the n? There you go. What is a to the m raised to the n? Yes. This is product. Yes. Power of products. What about if you have ab raised to the n? A to the n, b to the n. So you guys remember this? Good. And if I have a over b to the n, that is? Yes. So by the way, we are assuming that a is not equal to 0, b is not equal to 0. Yeah? So that's your assumption. Okay, so what about, for example, a over b raised to the negative n? I don't want to have the negative exponent. What is a over b raised to the negative n? How do I get rid of the negative exponent? What do you do? Take the reciprocal? Yeah, so this is b over a to the n, which is equal to b to the n over a to the n. All right? Okay. So let's just simplify the expression. So do we need examples? Probably not, right? Simplify each expression. Right, using positive exponent only. All right, so number 1. 12x squared y to the 4 multiplied by half x to the 5th y. Number 2. x to the 9th times 2x to the 4th divided by x cubed. Number 3, rs cubed times 2s to the negative 2 times 4r to the 4th. Number 4, x squared y cubed raised to the 4th, xy to the 4th, negative 3, divided by x squared y. Okay. What time is it? Is this clock accurate? 8:31, 32? It is? Oh, okay. Oh, that's right, yes. So I didn't adjust my clock. It was still East Coast time. That's why. All right. Are you guys done? Okay, so how would you do number 1?
The first law,
Yes.
maybe 6x to the 7,
Right.
y to the 5.
There you go. How do I get x to the 7 and y to the 5th? So as, what's your name again? Alex said it was, you used the first law. So far so good? No question? Okay. Now, what about number 2? So we have to do the exponent here first, right? 2x raised to the 4. What is 2x raised to the 4? 16x to the 4th. Okay, and then divided by x cubed. All right, so what do we have? What about the coefficient? The coefficient? What is the coefficient? What's the number? 16x to the, so 13 minus 3, which is 10. Okay. So some of you can write this, or some of you can write 16x to the 13 divided by x cubed, which is 16x to the 10. So you could do it either way. Yeah. So if you want, you could write, if you know you could do it on your head, then you could just write 16x to the 10th. Or you could say, oh, let me write these intermediary steps. Do I require you to write the intermediary steps? No. Just if you need it, you can write. If you don't, then you don't. Yeah. So this one is optional. Okay. Now what about the next one, number 3? what would you do first? Bring the 2s down? Okay, so what about this rs cubed? How do I rewrite rs cubed? Yes, r cubed, s cubed. Alright, good. Now you said that we have to bring the 2s down. Why do we bring the 2s down? Okay, so what do I have on the bottom? 4s squared. Why is it 4? Why isn't it 2? Okay, because we square the 2 and we square the s. Right? Okay. And what about these on top? What else do I have? 4 raised to the 4th power. What is that? 256 r to the 4th. Okay. Are we done? Okay. All right. So let me move this a little bit. Okay. Now, what do we have here? Oh, well, maybe I should write it here. 256 divided by 4. 64. Okay. What about the r? So 64 r to the 7th. What about the s? S. So 3 minus 2 is s to the 1st power, which is s. Are we okay so far? Yeah? Okay. How about the next one? What do we do here? X squared to the 4th. What is x squared to the 4th? X to the 8th, y to the 12th. Actually, we could just leave it here. So this is x to the -3, y to the -12 divided by, what is this? X squared y. All right. Good. So now, what x's do I have? Uh, 8 minus 3. What is 8 minus 3? 5 minus 2. 5 minus 2 is 3. So x cubed. What about the y? Oh, the y cancel. And then what is this then? Y to the what? -1, or I have to put the y below. Yeah? Does that make sense? So you could just put the x and the y wherever we want, and then here, if we put it on top with negatives, so you have two choices. Like this, what happened here? We write it down. We bring it down, right? Here, what happened? So I treat these two differently, right? Can I bring the x cubed and y to the 12th down, actually? Yeah, I can. Or can I leave it up? Yeah, so either way works. Yeah, I just want to show you both ways. So here, when I have negative, I bring it down. But here, when I have negative, I keep it up. But I distributed the negative exponent. Right? Okay. Easy? Okay. Good. So next is scientific notation. Yeah. So B, scientific notation. Ready? Okay. So B, scientific notation. All right. So what is the scientific notation? So a number is written in scientific notation. Why do we use scientific notation? You mean it's too big, right? Yeah, it's too big or too small. Expressed as n times 10 to the n, where Oh, maybe I used the book. Time today. Where A has to be between 1 and 10, and N is an integer. All right. Good. So, rewrite as decimal. Number 1. 5.2 times 10 to the 7th. 3.72 times 10 to the negative 7. How do I write 5.2 times 10 to the 7th? 7 decimals? Okay, so what is this? So you have 5.2, and then you're going to go 7 decimals, right? So this is your first one. So you're going to do 1, 2, 3, 4, 5, 6, 7. So how many zeros do we have? 6. Okay, so 52 million. All right. How about 3.72 times 10 to the negative 7? So we go the opposite direction how many times? 7 times? Okay, so 1, 2, 3, 4, 5, 6, 7. Oops. Here. So how many zeros do I have? 1, 2, 3, 4, 5, 6. 0, 0, 0, 0, 0, 0. 372. So as you can see, these numbers are either big or small, very small. What do you think is big? Why do we even need it? Like 52 million doesn't seem that big to me. But what is big, for example? Maybe the math. Yeah, go ahead, Jacob, right?
Yeah.
Mhm. Okay, so mass of atoms. So mass of atoms, is it really big or really small? The number of, yeah, so is it big or small? Really big. The number of particles in an atom. So for example, the mass of the planet is big also. So what's really small? The mass of an atom, right? The mass of a particle, that is really small. So that's why we need scientific notation. We use it in science. Now, what about if we do it the other way around? Rewrite using scientific notation. So number 1, 375 with, I don't know how many zeros here. Million, 6 zeros. And then 0.0000257. And we also have number 3, 803 times 10 to the negative 5. And then number 4, 5.1 times 10 to the negative 3 divided by 2 times 10 to the square times 6.2 times 10 to the 15th power. Well, on the last one, you probably need calculator, right? Okay, can you at least do the 3 of them? And then we'll do the last one together. So sorry, I'm going to do the scratch here. Alright. So, what is 375 million? How do I write my scientific notation? 3.75. Why don't you do it 37.5? Why would you do it 3.75? Yes, it says it has to be between 1 and 10. Yes? So, how many here? 1, 2, and then 3, 4, 5, 6, 7, 8. So 3.75 times 10 to the 8. Okay. That's right. How about the second one? Yes. So why do I need 2.57? It's the same thing. It has to be between 1 and 10. Yes. So 2.57 times 10 to the what? Let's see. 1, 2, 3, 4, 5, 6. Yes, negative 6. Are we okay so far? Okay. Now what about these? 803 times 10 to the negative 5. Is this in scientific notation? Not really. Why not? The 803 here, this is greater than 10. So it should be what? 8.03. Okay? So what I'm going to do is 8.03, I'm going to change 8.803 as write it in scientific notation. So how do I write 803 in scientific notation? 8.03 times what? 10 squared. Is it? So this gives me 803. But I still have 10 to the negative 5. So this is your 803. So at first, I'm not doing anything with my 10 to the negative 5 yet. Did you see it? Did I do anything with my 10 to the negative 5 in the beginning? No. So what I did was I converted this part, 803, into scientific notation, 8.03 times 10 squared. Now, what am I supposed to do now? Combine this. So this is 8.03. What about 10 squared times 10 to the negative 5th? What is 10 squared times 10 to the negative 5th? 10 to the? All right. Are we okay so far? Okay, so we're doing it an easier way, right? So we're not doing anything with the 10 to the negative 5 until later. Yes? Okay. So let's do the number first. So what I'm going to do is I'm going to simplify these. What is 5.1 divided by 2 times 6.2? So can you use calculator and then give me a number? So 5.1 times 6.2 divided by 2. What is it? So we're doing the number part first. 15.81? Thank you. So those are the numbers only. Now we will deal with the powers of 10. 10 to the negative 3 times 10 to the 15 divided by 10 squared. So I'm dealing with the number part, and then I'm dealing with the powers of 10 later on. Okay, so what about my powers of 10? What does this give me? So negative 3 plus 15 minus 2. So this is 10 to the 10th. All right. Are we okay so far? Okay. Now, my next question is 15.81, is this in scientific notation? No. So what am I supposed to do to change it into scientific notation? Move the decimal where? Okay. So it will be what? 1.581 multiplied by 10 to the first power. The first power, we usually don't write it. So this is an invisible 1 here. 10 to the first power. Well, this is an intermediary step, so we could write it. As a final answer, if it is 10 to the first power, we do not write it. Well, think about 15 and 1.5. All right. So if you ever doubt, is it multiplied by 10 or 10 to the negative 1? This is what you should do. So 15 is what? 1.5 multiplied by 10. Yeah, that's how you think about it. So we don't get confused. Okay. So then what am I supposed to do now? Combine the 10. So what is this? 1.581 times 10 to the 11. All right. Are we okay so far? Good. Now, oh, it's already 8:51. So let me ask you a question. How many people got their Math Excel? Okay, how about the others? Sometimes before Tuesday next week or Wednesday next week? Okay. So I'm going to assign homework from the book for 1.1, 1.2, up to 1.5. Okay? So up to 1.4. Let me see which one it is. So homework 1.1. So can I safely assume by Wednesday next week you have your Math Excel? Okay. So 1.1, all right. So homework for 1.1 is from the book, number 1 through 71. Let me see. This is really easy. Maybe odd is okay. Yeah. There's some applications too. So 1 through 75. I'm sorry. This is really easy. Some of them you're just property of real numbers, commutative. So what I'm going to do is on chapter 1, I'm going to give you a take-home test. Yeah. So a lot of these you have to do it on your own. So properties of real numbers, so commutative, additive, property, addition property, those things I'm not going to discuss. So a lot of things in 1.1 in chapter 1 I do not discuss because these are review. So something like this, interval notation, I think it's important. That's a scientific notation. We use it all the time. That's why I review it. But a lot of things in chapter 1 I will not review. But I'm going to give you a take-home test. Okay? All right. So are we okay? So 1.1, if you want to start with 1.2, let me give you the numbers also. I think it is 1.2, number 1 to 97. 1 to 97 every 3. What do I mean every 3? So number 3, number 6, number 9, number 12. So multiples of 3. Okay? So you can get started. And it's a long holiday, so I will see you when? On Tuesday. I'm going to collect homework 1.1 and 1.2 on Wednesday. So on Tuesday, I will finish 1.2, and I will collect homework 1.1 and 1.2 on Wednesday. I'm sorry? 1 through 97. Okay, multiples of 3. Are we okay so far? Okay. All right, you guys have a good long weekend. I will see you on Tuesday.
I got a question about something real quick.
Yes.
I didn't see in the syllabus or anything about like makeup tests or anything like that.
I don't give makeup tests.
The reason why I asked is my wife is pregnant and she's due in November, but we don't have a scheduled date yet. So.
Oh, hold on. Let me close the recording because otherwise it's getting recorded. Okay, hold on.